Hello? Hello? Is this on? All right, here we go. This is my very first YouTube video that I've ever made, so I expect it to be a little bumpy, but hopefully it goes well today. If you don't already know, I am away at a math conference, and so hopefully this walkthrough of the lesson that you're supposed to have for today is good enough of an explanation that you guys can do the problems that I'm going to assign for tonight. Now, as we get started, like I said, I'm away at a math conference, probably sitting down with some super math nerds right now and telling some crazy math jokes, and so I know you all are jealous and you wish you were with me, but hey, you know, there's only certain people that can be math teachers. By the way, have you heard the one where the bird flies out the window, the parrot flies out the window, and what's the owner say? Anybody? The owner says, "Polygon." Come on now, you gotta laugh at that one. Anyways, here's what the goal of today's lesson is. I'm going to be giving you different proofs, and I'm going to ask you to basically identify what parts are overlapping in order to know how to solve certain problems. And so if you take a look now at the very first proof that you have on the top of your paper there, you see that ZW is congruent to XY. We have that marked out, congruent. We also have angle YXW congruent to, or not congruent, is a right angle, as well as ZWX. Now, what I want you to think before we get started here is, which two triangles do you know the most information about? And since we know about the two segments and the two right angles, we know the most information about triangle ZWX and triangle YXW. And so what I'm going to do, and what I would encourage you to do on your homework tonight when you have these problems, is to go ahead and redraw the triangles and label all the parts that you currently have. Okay? Now, as we want to go ahead and prove these two triangles congruent, the first thing I would ask you to do, based off the two triangles that you already have, is which segments are shared. And if you look, you notice that WX is in both of the triangles that I've redrawn. Hopefully you can see a little more clearly than before. And I'm going to go ahead and prove those two congruent to each other by the reflexive property. Okay? Now, I would hope that you're thinking in your mind, you're thinking to yourself, aha, I've got side angle side. But I'm going to slow you down. I'm going to stop you right there. We don't have side angle side because all we have right now in congruency is side, side, and side, side. And so in order to get side angle side, we are going to have to state that angle ZWX is congruent to angle YXW. And the reason is because we know they're already right angles. And so as a result, we're going to say all right angles are congruent. Okay? It's important that when we're proving congruent triangles, remember we have to have those congruent parts, whether it's side, 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 or side angle side, or angle side angle, or angle angle side. Or even hypotenuse leg later on. And so don't leave those parts unproven congruent, even if they're marked congruent within the picture like this one was. And so from there, we know that the two triangles are congruent. By side angle side. All right, now for our next proof, I'd encourage you probably to press pause on the computer right now and just think to yourself, with the angles of ABC and DCB being congruent, and angles CBD and BCA being congruent, which two triangles do we know the most about? Okay, Now if you look, if I go ahead and I'm going to highlight this first triangle here, this triangle right here, ABC, we know two of the three angles. We know this angle here at C, and we know this angle here at B. And so I'm going to pull that one out. See if I can grab only it. Yeah, that's kind of cool. Okay. And I'm going to highlight the other triangle that would correspond with that. And if you notice, this angle at B, we know is congruent to this angle at C. And so I'm going to do the same thing there. I'm going to pull that one out. If I can. Yeah, there you go. Okay. Now, I'm going to relabel them as they're labeled up in the picture. And I'm going to mark the congruency marks that were given within the picture. Okay? From there, I would ask you to think about what is shared between those two triangles. Is there anything that's already in common? And as we look at the two triangles there, I hope that you realize that BC is in both triangles. Therefore, it's got to be congruent to itself, again, by the reflexive property. Okay? And so, if I go ahead and mark the congruency there, well, that was easy. We're trying to prove those two triangles congruent, and what do we see? We see that those two triangles are congruent by angle, side angle. Okay, so those are two pretty basic proofs where we have some overlapping parts, and hopefully that was clearly understood as to what we're doing. Now, we're going to flip over to the back side, and we've got some proofs on the back side that are a lot more detailed, and so I want to take a look at those with you guys. And so go ahead and turn to the back side with me, and we'll see how to do those problems. All right, so if you take a look at the back side of your worksheet there, I'm going to skip the first one. We're going to do that one in just a little bit, but there's some little details there that you guys haven't been introduced to yet, and so I don't want to jump right into that. We'll do that one last here. And so as I look at the middle proof on the back side, again, I encourage you to pause the computer here and see if you can figure out which two triangles we want to prove congruent first. Which ones do we know the most information about? And then redraw those and mark what's already been given. Okay, so do that right now. All right, so if you paused it and you actually tried to look over what we are given within these two triangles, which ones we're going to want to prove congruent, here's what we have, okay? This triangle right here, ZWX, we know that we have this small angle here and this larger angle at W congruent to two of the angles of the other triangle. So I'm going to go ahead and take that triangle, just grab it. Yep, and move it out. And I'm going to do the same thing with the other triangle here. And I'm going to move that one out as well. Okay, so we've got those two triangles that we're going to try to prove congruent. Now, I'm going to label the vertices. And then I'm going to mark the parts that are congruent already from the given. Okay, so from there, I would encourage you to look at the picture that I've drawn up there and ask yourself, what parts overlap? Is anything shared? And what I hope you see is that WX is in both the triangles. And so again, we're going to use that reflexive property. I told you we'd use that a lot in this chapter to prove them congruent. Now, I hope you've gotten to the point now where when just looking at a picture of two triangles, one of the four ways that we've already talked about to prove triangles congruent. It just pops in your head. And so as I look up there, oh, I've got angle, side, angle, angle, side, angle. So therefore, the two triangles must be congruent. And so if I write this down, ZWX will have to be congruent to YXW. But you may be saying, well, Mr. Couples, the proof isn't to prove the triangle's congruent. The proof is to prove ZW congruent to YX. Well, if you look, since we have the two triangles congruent, like we talked the other day, I said that once you've proven those two triangles congruent, all the other parts, this segment here, and this segment here, this angle here, and this angle here, and this segment here, and this segment here would all have to be congruent. So as a result, I'm going to go ahead and say that ZW is congruent to YX because corresponding parts of congruent triangles are congruent. Okay, it's very important that you remember that after you've proven the triangle is congruent, you can use that to justify any other part of the triangle. And so I mark that out, and we are done with that proof. Okay? Now, I want to move up to the top of this worksheet and do our very last proof. All right, and I said that this proof was a little bit different than the other ones, okay? And so you're going to see that play out here, but hopefully it makes sense to you. So first thing I want you to do, again, I would pause your computer, your movie here, and see if you can figure out which two triangles we want to prove congruent. Okay? Now, obviously I'm giving you the proof there, which is going to be this triangle here. That would be PLN. If I can pull that out. Okay, there's PLN. And the other triangle, LOM. All right, and marking the vertices here. And marking specifically what we're given up here in the given, that LP is congruent to LO, I can go ahead and mark this side congruent to that side. Now, I don't know anything else other than what's already been stated from the given. And so some of you may be thinking to yourself, well, I know that ON is congruent to PM, and I know that LO is congruent to LP. So wouldn't this side here have to be congruent to this side over here? And the answer is yes, but how do you show that within a proof format? And how you show that is by doing this. You know from our first chapter that if I take LO and add in ON, that will equal the entire segment of LN. Okay? And you also know that if I take LP and add in PM, that is going to equal the entire segment of LM. Now, what's that called? Do you remember from the first chapter? If I take a segment plus another segment that equals the entire segment, that is called the segment addition postulate. Adding two segments to equal an entire segment. Okay? Now, you also know from chapter 2 that if I take LO, well, from the given, we're told that's equal to LP. Okay, so this equation is still equal. But if I add in ON with PM, again, the equation is still equal because I've added the same thing to both sides of the equation. Now, what's that called? Well, that's just simply the addition property of equality. Okay? You're adding the same thing to both sides of the equal sign. Now, if we combine steps 2 and step 3 together, we would then know that ln has to be equal to lm. And how is that? Well, if ln equals this, I can put ln in for that. And if lm equals this, then I can put lm in for this. And remember, that is called substitution. Okay? So I'm going to go ahead and mark this with this. Okay? Now, up until now, we still don't have congruent triangles. We don't have side, 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 angle, side, angle, or angle, angle, side. And so what I want you to be thinking is, what's shared between the two triangles? What's the overlapping part, like in all the other triangles that we've looked at so far? And the overlapping part, unlike the other triangles, which all had line segments as the overlapping part, the overlapping part is going to be this angle right here. It's the same angle in those triangles. And so if you want, because there's only one angle coming from that vertex, you can go ahead and say angle L is congruent to angle L by the reflexive property. Okay? Now, boom, you got side angle side. So you can go ahead and state the proof, which is triangle OLM is congruent to triangle PLN by side angle side. Okay? So, class, here's what I want to make sure that you got from today. Know how to draw the triangles separate of each other and identify their overlapping parts. If you struggle with that, again, look at my website, but that's really the key for everything that we're going to be doing over the next couple of days. These proofs are going to continue to get a little more complex. And so if you can't separate those two by drawing them separate, you've put yourself at a big disadvantage. So again, I thank you for listening to me. I realize that hopefully I didn't put any of you asleep in the short time that I've been talking, but you can go ahead and get started on your homework. The homework is on my website, and I will see you on Monday. Good night.